Good day, students. My name is Deborah and today's video I'll be taking you through tropical cyclones with SmartPrep. So I hope you've got your books ready and your pens ready, and we'll get right into the video. And do not forget to like, subscribe, and share with your friends as well. Okay, let's get into it. Good day, students. My name is Deborah and today's video I'll be taking you through tropical cyclones. So what are other names for tropical cyclones to begin with? They're usually called hurricanes in America or typhoons in China and Japan. They're also called willy willies in Australia, and they're given names alphabetically within the season in which they occurred. For example, if you have a name of Alfred, it would denote that it is the first tropical cyclone to hit or to occur in that season. Right. So some of the things that we will learn in today's video includes looking at the key concepts of tropical cyclones. We'll look at the area of development, the characteristics, conditions for development, stages. We'll look at satellite images and synoptic weather maps. We'll look at weather patterns, impact on humans, economy and environment, as well as strategies to minimize the impact. So it's quite a lot that we have to cover, but I'll try to explain them well enough. Right, so let's begin by looking at some definitions that we will encounter. So the first one says adiabatic heating. So this occurs when air descends and compresses, which results in very little precipitation, right? And then we have adiabatic lapse rate, which is the rate at which the temperature of an air parcel changes in response to the compression or expansion that occurs due to elevation change. And we always assume this is a adiabatic process. And that basically means that there's no heat exchange that occurs between the air parcel and its surroundings. So as we discuss this more, it will make more sense. And the eye is the calm area at the center of a tropical cyclone. So if you're ever at the eye of a storm. And then what is a tropical cyclone? This is a powerful rotating storm system that forms around a low pressure cell that develops over a warm ocean between the tropics. And then usually we have the eye that moves over land. And then what is a waterspout? This is a weak tornado that forms at sea in association with the storm clouds of a tropical cyclone. All right, so we'll now discuss what tropical cyclones are. Let's discuss a bit of the area of development of tropical cyclones, right? They usually develop between latitudes 30 degrees north and south, right? It's usually the result of the confluence of the tropical easterlies at 5 degrees north to 30 degrees north, and then 5 degrees south to 30 degrees south of the equator, right? And then they do not usually develop on the equator and 5 degrees, but are usually found 5 degrees north and 5 degrees south because of the weak Coriolis force that deflects the wind. So remember in the earlier videos we talked about this different force and wind systems, right? So the Coriolis force sort of makes it push 5 degrees upwards, right? And you can see in that map the time regions that it usually occurs within different parts of the world as well, and the different names that they are called. So what are some of the conditions necessary for the development of a tropical cyclone? So the first thing is we need it to be 5 degrees north and south of the equator, as I mentioned earlier, and this is because of the weak Coriolis force at work at the equator. And then we need the ocean to be warmer than 26.5 degrees Celsius. This is because the warm water has a high evaporation rate that therefore feeds the low pressure system. It usually develops only over the tropical oceans because there's less friction over a smooth surface, right? So the odd moisture air that is greater than 26 degrees, creates unstable air that continues to rise. And then that unstable air results in condensation, which is then going to release latent heat into the atmosphere, and then that produces more energy. So it's a system that sort of feeds itself, right? Let's continue. Another thing is that we need the surface air to converge, right? Which means they need it to meet together, and therefore this forces the air to rise when it converges at a low pressure system, and then that happens at the surface, right? And then in the upper atmosphere there's a divergence. So it's sort of the air moves in the surface and then converges to the surface, it rises up and then diverges. So there's more moist air that is drawn into the system at the surface as the air diverges in the upper air. Then the intense low pressure cell is enhanced by the tropical jet stream in the upper air because of strong surface convergence, convection, and upper air divergence. So because of all this, as the system is feeding into the south through convergence and convection and divergence, there is now an intensified low pressure cell. And we also again need the Coriolis force to cause spiral winds, which is basically the deflection of air, which results in the clockwise circulation in the southern hemisphere. So remember, the air circulates clockwise in the southern hemisphere. So the source of energy of this tropical cyclones is the latent air, the latent heat rather, which is released as warm, moist tropical air condensers, right? So again, it's a system that sort of feeds itself due to the latent heat. So the source of energy of this tropical cyclones is the latent air, the latent heat. So some of the characteristics of tropical cyclones is that we have an intense low pressure system that's usually below 1,000 hectopascals. It's usually found in late summers and autumns over warm tropical oceans, as mentioned earlier. There's a clockwise movement of air in tropical cyclones in the southern hemisphere, and then the steep pressure gradient increases the wind speed, and this can be winds up to 300 kilometers per hour, which is very gusty. And then it usually moves from west to east within the tropical easterlies. Right. And we also have the eye. If you can see in that image there, there's that center. That's sort of your eye of the storm, which develops in the center of low pressure. And you have your high cumulonimbus clouds that forms the eye wall, which presents heavy rainfall, hail, storm surges, and hurricane winds. Again, as I mentioned earlier, it receives alphabetical names and affects usually the east coast of continents, and that's because of the positioning next to oceans. It develops only over oceans and dies out over land because of friction and therefore the lack of moisture. So we need that moisture that will sort of feed the system consistently. Right. We're now going to look at the stages of development of a tropical cyclone. So there are four main stages. We have the initial stage, development stage, mature stage, and decaying stage. And as we go through this, I want you to begin to compare and contrast this with the mid-latitude cyclones that we've discussed already. Right. So the first stage is the initial stage, right? And we have, again, the convergence of air towards a low pressure cell, which creates a vortex, and we usually have air pressure that is about 1,002 hectopascals and wind speeds that are up to 60 kilometers per hour. So if you can see on that image, you need a temperature of like above 26 degrees Celsius. So that's the warm air, and then the air is converging towards the low pressure in a clockwise direction. Right. Then we have the development phase, which is there where we have the intensity of the storm increasing as the air continues to converge. So it converges and then it rises in the low pressure center, and then divergence happens in the upper atmosphere. So just imagine it's sort of like coming in and then going up and then diverging. The air pressure therefore drops below even to 990 hectopascals. The wind speed increases to about 120 kilometers per hour. The eye begins to form in the center of the low pressure, and then we have huge cumulonimbus clouds that form the eye wall around the eye, right? And then this also forms around the eye and swells to form a vortex. The third stage we have is the mature stage, where now we've reached the maximum intensity of the storm. The pressure drops to about 950 hectopascals. The wind speed is great, above 180 kilometers per hour. The eye is like raging on. It's clear and cloudless, again due to the adiabatic warming of subsiding air. The vortex is now well developed, as you can see in that image on the right, where it's like it's just swirling very quickly, and that's up as wide as 600 kilometers in diameter, and you will have things like torrential rain, thunder, and lightning. So you can imagine the devastation that a storm like this will cause, right? And then, as we would hope, it decays and it comes to an end slowly. So the air cools down when entering the temperate latitudes. The cooler air flows into the cyclone, increasing the pressure. And then when it moves inland, the supply of moisture is therefore cut off, and the surface friction slows it down. So ironically, we need the storm to move towards the land so that it can sort of slow down, but even that will still bring some level of devastation. Alright, so this image sort of shows you the cross section that you can expect through a tropical cyclone. So behind, so you can see there's two regions there. A bit further to the left, we have cumulus clouds, which would give you sort of lighter rains. And as this air is now converging and rising up, we have cumulonimbus clouds that are forming, and then heavy thunderstorms. And then, as you can see, once the air subsides, there's not much rain. It's a bit lower pressure. So again, that's why the eye of the storm is calmer. So that's the low pressure. And then to the other side as well, they have that cumulonimbus clouds. So it's like both sides. There's a lot going on. There's thunderstorms and lightning and all of that. But in the eye, it's calm because of the air that is subsiding. All right. Okay, so now I'm going to show you the presentation of tropical cyclones on satellite images. As you can see, if you look at those arrows that have been pointed, you see the eye that has been formed. So once you see that funky little, not S, but that, I don't know what shape to call it, I guess it's sort of like a S, but the center is bulging, that's your cyclone, the eye of the cyclone, right? The active quadrant is the strongest area of a tropical cyclones, and when the winds rotate around the storm center, it coincides with the winds moving the cyclone system from east to west, right? And then the forward left-hand quadrant is more active in the southern hemisphere. And you begin to, again, have an appreciation of how strong those knots are. You can only expect overcast regions in the weather station. So you begin to tie all this information together, looking at the low pressure south that would obviously exist as well. Right, so what are some of the associated weather patterns I said before? So the first image on top is sort of familiar to us. You might also have, again, with this one it shows us, you might have cirrus clouds that are a bit over there as well. So in the active quadrant, you can see that active quadrant that we were talking about on the previous slide. The air is moving a bit clockwise, and you can see that the pressure is decreasing into the subsiding air. The wind speed is also decreasing into the eye of the storm, but on either side, the rainfall is sort of rising up. So if you look at 1, for example, the pressure is dropping all the way, and then by 4 and 5, which is when now we're reaching like the decaying stage, our pressure rises, but it's still low, then it normalizes. So 5 is when the storm is over. Towards the left of it, you have 27, so we need it to be very hot, and then the temperature will drop at 2 due to the cloud cover, because of the rain that's happening. And in the center of the storm, in the eye, it rises to 28 degrees plus due to adiabatic heating as well, and then at 5 it normalizes. Wind speeds is usually very high. It's strongest in the cyclone, but in the eye it's calm. Everything is just calm in the eye. At 4 as well, the hurricane strength is also the wind. Rainfall at 1 is light because that's still building up, but 2 and 4 it's like very heavy rains. But in 3 again it's clear. So 3 is just having the time of its life. It's the eye, right? It's just really safe in the eye. So now we'll discuss the impact of a cyclone like this on humans, economy, and environment. And as you can imagine, it's not going to be great, right? So for humans, for example, torrential rain will result in the risk of flooding. The winds will damage and shatter windows and rip off roofs. We've had a few in South Africa as well. And the storm surges can cause damage to the coastal areas. Infrastructure will be destroyed, bridges, roads, houses, water pipes, which results in the lack of fresh water actually. The wind and water also damages our power lines. There's deaths and injuries of people, animals because of the storm surges. There's starvation because of lack of food. There's outbreak of diseases, waterborne diseases like cholera, typhoid. There's financial strains on family because there's a lot being lost. Subsistence farming, there's going to be loss of everything. And then the swell of the waves is also dangerous for fishermen and humans in general. So it's not a great time for anyone during a storm. In the environment, it's the strong winds will cause storm surges, which will cause a rapid rise in sea levels. The floods and salt waters destroy agricultural crops. Flooding and rising river levels cause of rain can cause mudslides and landslides, which will destroy our ecosystems and biodiversity. The livestock will drown. There's lack of clean water, food security, strengthened sewage pipes are damaged, which will result in pollution. So again, it's not great. And then economy, airports would have to be closed because we can't travel, during heavy rain like that. The harbor facilities will be damaged, businesses are closed, trading is not possible. It's now costly to repair all of this, jobs are lost, unemployment, medical expenses are high, insurance is high, puts a strain on local civic services, limits exports, increases imports because now we need more food and other commodities. So again, it's just terrible financial strain on everyone. The environment suffers, humans suffers, our economy at its all suffers. So what do we do about this? So what are some of the strategies that we can do to minimize the impacts of tropical cyclones? Firstly, we have to monitor the development, especially in the initial phase, to ensure that we put in the following into place. We would have satellite tracking, which can monitor the development and path, satellite sensors to collect details such as rainfall rates, advanced weather predictions and warnings, communicate those warnings to people to prepare, and you'd evacuate to low-lying areas to protect people against flows. So you evacuate from low-lying areas, ensure that infrastructure is of very good quality that can withstand that, keep livestock in barns to protect them against wind and rain. People should stay indoors to protect themselves against the heavy rains, flying debris, and rain. Upgrade the technology in low economic developed countries. Good medical care will reduce outbreak of diseases. Good medical emergencies should be well equipped, and lastly, local civic or emergency services should be well prepared to assist. So everyone just needs to brace themselves, and be warned ahead of time and protect themselves beforehand. But there's no avoiding the storm once it comes, right? Okay, so this is an exercise, and there's a timer there. I'll give you about 1 minute to complete. Right, so we're supposed to use a figure 7.1 to choose and describe based on the images, so the words that are there. So 7.1.1 says cloud A is A. So obviously that's a cumulonimbus clouds. That's what we'd expect in that region. 7.1.2, the updrafts are at B are caused by convection currents, right? We never talked about advection currents, but it's convection currents at B. And then area C, because that's the center, is the I. Area AB would be the eye wall or at the edge of that. 7.1.4, the atmospheric condition experienced at sea is unstable, right? D indicates an area of convergence. As you can see, there are two arrows that are coming in. The top of C would be divergence because the arrows are going out. So just look at the arrows if they're given to you. And then 7.1.6, E will experience thunderstorms. So as you can see, those rains are very heavy. And then 7.1.7, ocean F is likely warm. So again, remember we need the warm, we need it to be at least greater than 26.5 degrees Celsius. All right. Okay, so with this one we'll do together because it's slightly longer. So it says study the case study of tropical cyclone Eloise, which hits Mozambique. If you want to do it alone, please pause the video and attempt it as well. So Tropical Cyclone Eloise made landfall early morning on 23rd January near Mozambique city of Beira, causing widespread damage and flooding on a long swathe of coastline and impacting an area still recovering from Cyclone Ida. So if you can see here that we've gone from Cyclone Ida to okay, so this is a different area. This is the neighboring southern African countries. They're also being hit by torrential rainfall and flooding from Eloise, which weakened to a tropical storm after landfall. Tropical cyclones Eloise made landfall at Category 1 strength with winds of 140 kilometers per hour and gusts up to 160 kilometers per hour. According to Mozambique's National Institute of Meteorology, Beira received 250 millimeters of rain in 24 hours, and other areas that were flooded ahead of Eloise landfall also received additional heavy rainfalls. Eloise impacted Madagascar before crossing the Mozambican Channel, killing at least one person. The Reunion warned of heavy rains in parts of Zimbabwe, South Africa, Botswana. The South African Weather Service issued top-level red alerts as floods swept through the northern part of the country, including the Kruger National Park. So Eloise poses a threat to the coast of Mozambique. So the rest of it's a major risk of coastal flooding. So how many tropical cyclones have occurred before tropical cyclone Eloise in the season? Give evidence from the satellite photos that Eloise is a tropical cyclone. Excuse me, bless me, sorry. Is a tropical cyclone in the southern hemisphere. In what stage of development is this weather system? Give a description of the characteristics of the storm in this stage, and then we are to describe the possible impacts that it will have on these three countries. Right. So the first question said, how many cyclones have occurred before Eloise? So because Eloise is the fifth letter of the alphabet, so it's A, B, C, D. So 4 had come before, because remember we labeled this alphabetically. And then it says, give evidence from a satellite photo that it's a tropical cyclone in the southern hemisphere. So the map shows southern African countries. This is 2 marks, so you can choose any of this. The cyclone path is from the eastern side to the west side. So that's the direction in the southern hemisphere. And then also you can see that the A is moving in a clockwise direction. So those are 3 things that tells us that it's a southern hemisphere map or cyclone. In what stage of development is this in? It's the dissipating state. And then it says, give some description. So at a dissipating stage, because it's sort of moving inland, right? The air cools when entering the temperate latitudes. The cooler air flows into the cyclone, increasing the pressure. When moving inland, as seen in the images, the supply of moisture is cut off and surface friction slows it down. So that any of those 2 would be good enough. And then it asks us to describe the possible impact that it would have. So obviously gusty, strong winds, and some of those words are from the paragraph itself. You would have strong winds, heavy torrential fall, coastal flooding, storm surges, rough stormy seas, damage to infrastructure or property, outbreak of diseases, loss of life, as shown that 1 person died, destruction of tourism, the Kruger National Park, the drowning of livestock, preparing for evacuation. So any of this, you can even write more than that as long as it affects, environment, humans, or the economy as well. Right. So this is another example. I'll read the article for us. So it says, tropical cyclone Dai is quickly strengthening into an intense tropical cyclone, has been fluctuating in intensity over the past 48 hours. An intense tropical cyclone is equivalent to a Category 3 hurricane. This cyclone is slowly moving in a westerly direction towards Mozambique, with wind speeds exceeding 170 kilometers per hour closer to the eye. Expected to reach the coastal area near Beira, Mozambique's 4th largest city with 530,000 residents before midnight on Thursday. So we have a couple of questions. I encourage you to pause the video and attempt them on your own. So the first one says, refer to the article, with what can you compare this intense tropical cyclones? And it says it there, a Category 3 hurricane. right? And then the next question says, name one condition that was necessary for the formation of tropical cyclones. So there's quite a few answers you could have given them. You need a temperature of 26.5 degrees higher, the sea surface temperature. You need unstable atmospheric conditions. You need the Coriolis force, as we discussed. We need calm conditions over the ocean surface. We need extensive upper air divergence of winds aloft. We need rapid large-scale evaporation of moisture over the ocean. We need the release of latent heat, right? And then the next question says, refer to the image and determine the expected wind speed with which the cyclone will reach Mozambique. We expect it to be about 120 kilometers per hour. And then question 4 says, why will the wind speed decrease as you move further from the eye wall? Because now the pressure gradient decreases when you move away from the eye. Then the last question says, explain how the dangerous semicircle of tropical cyclone Idai originated and developed. And then lastly, in a paragraph of approximately 8 lines, suggest the negative impacts that it will have. So particularly for the last question, you can expect that to come for 8 marks. Like that's been standard so far. Right. So some of the conditions that we needed for this cyclone to develop is that you needed the circulation and forward movement in the same direction. You needed intense winds in the cyclone, which combines with the force of the entire cyclones moving forward or westwards into left-hand quadrant. So this is basically talking about the active quadrant that would form. And then the effects of this is that the storm surges due to strong winds will flood coasts. There would be damage to property because of flooding of low-lying coastal areas. There would be loss of human life. It would cause coastal erosion. So again, you need to be specific to the area. So if it's a coastal region, you would speak about coastal effects. If it was more of a tourist effect, tourist area, you speak more about that as well. Ecosystems are disrupted. Damage to property, destruction of transport infrastructures like harbors and stuff. So those are things that we would discuss. All right. So thank you once again for watching this video. Do not forget to like, subscribe, and share with your friends. And I hope it helped you. And keep, get ready for the next couple of videos as well as we continue on this topic of cyclones and anticyclones. All right. And thank you so much to our members. And I'll see you in the next video. Bye.